All right, so now we are starting to get into logarithms and natural logs that you haven't seen before. It is a little weird at first, but once you do it a few times, it's actually not that bad. It just looks weird at the beginning. So here is how you go from exponential form to log form. So you have a to the x equals b. So whenever I think of it, I'm like, okay, and so this part is called, this is called your base. So which log base are you using? So it's the base to whatever it equals, so in blue, equals the middle part. Okay, and so what is this? So logs are used for a few different things. They're all used for exponential functions. A lot of scientists use logs. So let me give you an example of what they do. So log base 2 of 4 is equal to 2. So what does that mean? So I'm going to take this 2, raise it to this power, 2, and that's going to equal the middle number, 4. Right? Is that true? 2 to the second power is 4? The answer is yes. Okay, let's do another one. Log base 6 of 36 equals 2. So this is like 6 to the second power equals 36. This is true. So that's how you would go back and forth. So I'll do it the other way. Let's do 4 to the second power equals 16. So how would you do that? You would do log base 4 of 16 equals 2. So again, that's just how you go back and forth between logs and logarithms. So let's do a few more. So we're going to rewrite these. You don't need to solve because there's nothing. There is a few to solve, but we're not going to solve it. So log base. What is your base? It is 2 for this one. Equals, so log base 2 of 16 equals 4. So that's how you do it. No, it's kind of weird. Let's do another one. Log base 3 of 243 is equal to 5. Log base 3 of 7 is equal to x. And the last one of these, log base 7 of 2 is equal to x. So again, in the next couple lessons, we're going to learn how to solve these, but we're not doing that today. All I'm wanting you to get used to is how to convert back and forth, back and forth. Okay, so now they're going to give it to us in log form, and then they want us to rewrite it in exponential form. So we don't need to solve it. Remember, it's 5. So the base to what it equals, so 5 to the second power equals the middle number every single time, 25. That's how I remember it. Is that a true statement? Is 5 to the second power 25? Yes. Okay, so the base to what it equals the middle number. Is 4 to the third 64? Yes. Okay, so now this one would be 9 to the x equals the middle number, 3. We're not going to solve it yet. That's coming later. Okay, and then this one's a little weird. So how would you write this? It's fine. It's the same thing. You're going to do 8 to the whatever it equals. So in this case, x plus 1 is going to be your exponent, equals 14. Okay, so now let's rewrite this expression using e's. So we're now using e, and we ran into e a little bit whenever we were doing that continuous formula, the p times e to the rt. The PERT formula is what I was calling it. So this one, how you convert from E problems, this is a different one. It's not a log, it's called a natural log. Okay, so natural log is it's the opposite of e's, so it's how you kind of get rid of them. So whenever you're doing this, instead of doing NL, which would make sense to me, they say like natural log like this, LN. So you probably, if you look on your calculator, you're going to see that button. You probably always wondered, what is that? But now you're finding out. So now let's talk about e's and how you get rid of them. So if you have a problem with an e and you want to get rid of it, because sometimes you need to solve for what's in this exponent right here, that's the whole point of this. If you had the number, you could just stick e to the whatever number in your calculator, but this is how you actually solve for that exponent, which you might have to do for a little bit, or in a little bit. So the opposite of e is natural log. So you're going to take the natural log, and if you do it to one side, you must do it to the other, because natural logs and e's cancel each other out, and this gives you, and you're left with x, because they cancel it out, so you just go to the exponent, it's how it works, equals natural log of 5. Okay, so let me give you another one. So if I have e to the x equals 3, you would do natural log of both sides. Those would cancel, and you would have x equals natural log of 3. So just know, sometimes whenever you are trying to cancel something out, if you're trying to get rid of an e, use natural log. One last one that I want to show you that I believe is on your quiz if I remember correctly. If you have natural log of e, what is that? Well, what happens, what is e's exponent? Well, if there is no exponent, it's 1, right? And what happens with whenever you have a natural log and an e? They cancel out, and so you are left with 1. Cool. Okay, so let's do some. So now we're actually going to start solving these. Okay, so there's a few different ways to look at it. This is how I like to do it. So log base 3 of 27 is going to equal, and I always say, right, equals x, because I like to think of it that way of like, what am I solving for? So first thing I would do is rewrite this in exponential form. So 3 to the x, because the base to whatever it equals the middle number. So 3 to the what power equals 27? Well, that would be to the third power, right? So if that was a third, 3 right there, that would be 27, because 3 to the third. So in this case, x equals 3. So the answer to this problem is 3. Okay, log base 9 of 3 is equal to x. So 9 to the x power equals 3. Well, this one's a little bit trickier, right? 9 to the what power is going to equal 3? Well, the only way I can think of to get from 9 to 3 is by taking a square root, right? Because off to the side I'll write square root of 9 equals 3. But do you remember how to write square root of 9 as an exponent? That would be 9 to the 1/2 equals 3, right? So in this case, x equals 1/2. Because remember, 1/2 is how you write square roots in exponential form. Okay, another one. So log base 8 of 1 equals x. So 8 to the x power equals 1. If you remember your exponent rules, what is the only thing that I could put in for x that would cause 8 to be 1? And the answer is 0, because remember, anything to the 0 power is 1. That's definitely something you need to know. Okay, so now this is a weird one. Well, not really. It's actually kind of easy. So I make it equal to x. So the base to the x equals 4 to the 3.6. Right? That's weird. So what does x have to equal in order to make those the same? Well, it's just got to equal 3.6. So even though it looks crazier, that's actually one of the easier problems. Okay, 5, equals x. 5 to the x equals 1/25. So remember your exponent rules. So 5 to the second power is 25, but then how do I get it to be 1/25? You're going to have a negative exponent. So 5 to the negative 2 power would equal 1/25, so x would equal negative 2. All right, let's do another one. Log base 6 of 1 equals x, so 6 to the x equals 1. This is like that number 3. How do you get a number raised to an exponent to equal 1? Well, that exponent needs to be 0. Okay, so another one. Just the more you see of these, the better you're going to get them, I promise. So 2 to the x equals 2 to the 5.4. What does x need to equal? Well, it needs to equal 5.4, right, in order for those to match. Okay, log base 5 of 25 equals x. So rewrite it. 5 to the x equals 25. What does your x have to be? X has to be 2, right? Because 5 to the second power equals 25. Okay, so 4 to the x equals 2. So whenever you're getting smaller, it's going to have to it's probably going to be a square root. So 4 to the what? Square root of 4 is 2, right? So how do I write square root of 4 as an exponent? Well, that would be 4 to the 1/2 equals 2. So x equals 1/2. All right, log base 3 of 1/27 equals x. 3 to the x equals 1/27. This one's a little bit harder. So I know 3 to the third equals 27, but 3 to the what equals 1/27? Well, that would be negative 3, right? Because negative causes them to flip. So x equals negative 3. Weird ones, okay? So set it up. Okay, this one you're going to have to do a little bit more thinking. It's okay. So 4 to the x equals 8. First step, we need to rewrite it. Okay, is there anything I can raise 4 to get it to be 8 that comes to your mind? Probably not, because if you're going to take a square root, that would be 2, so that's getting smaller. That doesn't help right now. If you raised it to the second power, that would be 16, so that's not going to work. So now we're actually going to have to do both, okay? So sometimes when you have these weird ones, you're going to have to do both. So you're going to have 4 to the 1/2, which is, don't forget, is the square root of 4. This equals 2. Can I then get 2 to be 8 by raising it to a power? Yeah. 2 to the third power is 8. So then, if you remember your exponent rules, you can write that with a rational exponent. So you could write 4 to the 3/2. That would equal 8, wouldn't it? Because that would be the square root of 4 to the third. You would always root it first. So 2 to the third equals 8. So yes, that works. So I know it's weird and you're probably like, ooh, that's really gross. I know it is, but you're fine. So this x is going to be 3/2. Let's do another one. Log base 9 of 27 is equal to x. 9 to the x equals 27. Same type of problem. So can I get 9 to be 27 by raising it to a whole number power? And the answer is no. So then what would it be? 9 to the 1/2 power. Whenever you're doing this, I would always start by square rooting it, because that's going to be a really common thing if they do. So square root it, and you get 3. Okay, well, I can get 3 3 to the third is 27. I remember that. So now if I write this as 9 to the 3/2 power, that would equal 27 because you would square root it first and get 3, then raise it to the third power. So x on this is 3/2. Okay? All right, so I already did this one up above. I didn't know it was later on in the notes. But so natural log of e, so remember those cancel each other out and you're left with whatever the exponent is. The exponent of this e, since there's nothing there, is 1. So whenever you do natural log of e, you literally get 1. Alrighty, 2 more. Ooh, this is a good one. Natural log of 1 over e. So what's another way I can write 1 over e? Remember that has a exponent of 1. You can rewrite this as natural log of e to the -1 power, because that's how you write fractions. Because whenever you do the -1 power, e to the -1 is the same thing as 1 over e. Okay, so now these cancel and you are left with -1 as your answer. Okay, last one. 3 to the x equals -9. So what 3 to the, I know 3 to the second power is 9, right? 3 to the, like that's how, if I do 3 to the -2 power, that would be 1 over 9. So that's not going to help me. What to the 3 to the what power is ever going to give me -9? And the answer is there is nothing that will. So whenever there is nothing that will do it, in which you may have one like this on your quiz, it's going to be undefined. Okay? So that is it for this lesson. I know it was a little crazy, but you can do this stuff. Make sure you do your homework so you're practicing this stuff. Have a great rest of your day, and thanks for watching.